Hi everyone, I'm Dr. David Jacob with Science Education Innovations. Today in this video, I'm going to walk through a New York State Regents-specific process for exam analysis. I'll be using examples from the biology Regents from January 2026, but the process itself is the same for all Regents exams. Before we begin, a few important clarifications. I do not work for the New York State Department of Education, and this video does not represent the department's official processes or positions. What I am is a science educator working to make sense of how these standards show up in assessment, in instruction, in lesson and unit design. The intent of this video series is to help teachers get closer to the intent of the standards using classroom usable processes that support how students learn science now. So you may want to pause the video and gather a few materials. You'll need a Regents exam you want to analyze, the New York State PK-12 Science Learning Standards, also known as NGSS, and the performance level descriptions for the exams that you want to analyze. You'll also need 3 highlighters, a blue, orange, and green. You can use yellow instead of orange, and a thought partner, like a colleague or someone to kind of check your thinking throughout the whole process. You can do this process digitally or on paper, whatever works best for you. So to frame this video, I want to name something important. Many teachers have not done this type of assessment analysis before. That's normal. We might have just looked at Regents exams, used them in classrooms, assessments and things like this. But the new work that we're working on is relatively new, and it asks us to think differently about what assessments are actually measuring. This video is not about judging Regents exam. It's not about critiquing item writers. It's about educator sense-making. We're here to understand how the standards present themselves in assessments so we can make better instructional decisions in our classrooms. One quick reminder before we go, the human beings who designed the Regents exams at the Office of State Assessment in Albany are former classroom teachers. The goal is not to trick students. Their goal is to design assessments that are fair, balanced, and valid to the standards. They are focusing on assessing how students think scientifically, not just what they can remember or recall. Keeping this context in mind helps our work stay productive. To ground our conversation, I want to pause and look at a slide from another video in this channel. The slide highlights something essential, the specificity of language at each grade band. In the standards, especially in the science and engineering practices, the verbs matter. For example, students aren't asked just to argue, they are asked to engage in argument from evidence. They're asked to construct, use, or present an oral or written argument or counter-argument based on data and evidence. This level of precision is intentional. The same is true for the cross-cutting concepts. Take cause and effect. At upper grade bands, cause and effect relationships can be suggested or predicted for complex natural or human designed systems by examining what is known as smaller scale mechanisms. Also remember the structure of the standards with the performance expectations and the 3 dimensions. The tricolored boxes at the end of each element are coded back to the performance expectation. And also remember the engineering, technology, and society standards, also referred to as ETS. They can be found at the end of each grade band standards, and these standards are explicitly assessed, as you can see in the test map, which we're about to discuss next. So step 1, map the exam. Using the test item map to the standards in the rating guide, code each question with its performance expectation. This step will allow you to see how the exam is intentionally constructed. You'll begin to notice patterns or groupings and design decisions that were made by the test owners that are easy to miss when you're only looking at individual questions. Mapping matters for 3 reasons. First, it reveals the structure of the exam, and second, it shows how multiple performance expectations are clustered together, which can be useful in your own unit design in your classroom. And third, it highlights how different disciplines work together in science learning, including engineering and systems thinking. Remember that the ETS standards are embedded in item clusters. One caution is just because we're following this pattern right now, that might be different in the future. Just keep an eye on what's happening at State Ed. This is how I coded a cluster here, which we'll go on to in a little bit further detail soon. So step 2 focuses on 2-dimensional and three-dimensional assessment design. How have the item writers used the SEPs, the DCIs, and the CCCs? Start by pulling out the standards and your three highlighters. Read the full performance expectation in the standard that aligns to the test map carefully. Include the clarification statement and the assessment boundary. Those details matter more than we think. Pay attention to the language. There are two ways to begin the analysis. If you're comfortable, you can try identify which of the dimensions in the item are being assessed from memory. Then check your thinking against the standard. Or read the elements in the tricolored boxes and notice how the item writer used all or part of the elements to construct the question. Both approaches are valid. Choose whichever one you feel most comfortable with. As you analyze, color code each question to show how the SEP, the DCI, and the CCC are being assessed. And once again, look back to the standards. You'll often notice that questions emphasize practices or cross-cutting concepts more than the content, like we saw in previous exams, previous versions of the Regents exam. Pay close attention to the word choice in the question, compare the language to the question and the language to the standard. This is where much of your learning will happen as you unpack all of these standards. After working independently, compare with your thinking with a fellow teacher or a thought partner. You don't need to agree right away. In fact, disagreement is productive here. What matters is your reasoning grounded in the evidence from the standard and the question itself. Here's what it might look like. Pause the video so you can pre-read the PEs from the first two clusters from the January 26, 2026 biology Regents that are listed on the screen. I will do a teaching strategy called a think aloud so you can hear my thought process. You can use think alouds with students to help them with sense making around a particularly tricky DCI or when you're asking a student to apply an SEP or a CCC in a sophisticated way.
So for this think aloud, I'm going to look at question number 1 on the January Regents. And as I look at it holistically, I'm not really looking at what I'm trying to get to. I'm trying to figure out what the question is really asking. So if I look at it first, I may go in with my science and engineering practice. And I look at it first, I go models. Here it is. So I'm looking at information from the models to identify which model represents fetuses that would continue to develop into identical twins. So I'm looking at it, I'm going, I think there's fetuses in the DCI, and I know that development is part of that too. So identical twins is kind of very specific, but there are lots of ways of looking at that DCI. So I'm looking at other things there, and I'm going structures. I may look at structures and say, structure and function is one of my cross-cutting concepts, so I'm going to put that there. In there. I'm also looking at this and it could also support my answer. So when I look at support my answer going, are they really asking me to argue from evidence? So when I look at this from memory without looking at the standard itself, I'm going to say, yeah, I think I've done a pretty good job. So when I look back, I'm saying this is holistically what the question is. But my students, I want them to start looking at the question and get them to start triggering their thoughts about modeling and things like that. Now I'm going to throw down the standards, and I've already coded this to say it is LS1-8. I'm seeing LS1-8 here, and LS1-8 here, and LS1-8 here. I've kind of pre-coded this for myself, and I'm going structures and functions of the human female reproductive system. So we're going, yes, that's there. Structures and functions of the human male structure. So I'm going, oh, structures over here. Even though I think of structure and function as part of a cross-cutting concept, here it is actually coded as my DCI. So I then go back and I say, what do I want to do with my model? So relationships between systems or between components of a system. So if I look back up here at my model, I'm going, this is the system that I'm looking at, system A and system B. So they're actually doing something that is comparing two models. So we're definitely working in modeling very well. So being able to compare two models and saying which one represents the concept that I'm looking at. third one I'm looking at, it's coded for systems and system models. And sometimes there's a lot of overlap between those two. But I'm looking here at interactions, matter, and there's one here that I didn't see before, which is information flows. There's one thing about these new standards that is kind of interesting. They look at DNA as information flows. They look at digital information as information flows. They also look at how the eye presents information. So information flows are put in some unusual ways. So it's one of the new pieces of vocabulary that we want to look at. So when I look at this and I say, okay, I feel pretty confident that LS1-8 are these three dimensions here. What I feel like I'm missing is that there's something from here. It is also simulated model, and it is all looking at interactions, and it's looking at information flow, and something at scales too, because it says here in my cross-cutting concept at different scales. So these are the things that are implied in this question, the third dimension that is implied in this that I can easily see there. There's not a word for me to code, so I put that off to the side. What this means for classroom instruction may be that I construct something very much like this in the classroom and then reiterate it in my own exams. So I'm now going to flip over to the ETS questions. Here, I'm using an ETS from a different cluster here. Oops, sorry, I wanted to use the ETS from, that is an LS, I'm sorry, here it is. It's question number 9 I was looking at. I want to show you how this can show up in another place as well. So in ETS 1-3, if this is the question that I'm looking at, I'm going to say, what are my pieces here? So I'm looking at a solution. I know solution is definitely part of a practice, which is constructing explanations and designing solutions. I also see a bunch of content here, but I'm going, this is an ETS standard. So I'm going, solutions are part of my ETS standard, but there's also some other things here that are weird. So I'm going to go, instead of relying on my memory, I'm actually going to go to the ETS standards here completely. And I look at this for ETS 1-3, and I'm looking at ETS 1-3 here. And it says, evaluate a solution to a complex real-world problem based on scientific knowledge, student-generated sources of information. I'm looking at what is here. In this cluster, there is so much scientific information. There are charts and graphs. There are readings. There are models. There are a whole bunch of things for them to look at. So when I look at doing an ETS question in the classroom, I have to provide the students with lots and lots of information. So if I'm looking at it, I'm going to say, this part is definitely part of my DCI, but of my practice. But if I look here in the coded for ETS 1-3, I see it here. I'm looking at a range of constraints, which include cost, safety, reliability, aesthetics, and to consider social, cultural, and environmental impacts. If you go back up to this prompt and all the way through the cluster, you want students to start thinking about looking at the cluster as a whole and how those other questions help inform this one. So when we're looking at all the different solutions that these students need to analyze, they need to look at what are the solutions that are taking in cost, safety, reliability, aesthetics, social interactions, cultural and environmental impacts. All of those are particularly challenging here, but I'm looking at it and going, without harming native populations. So that's really what we're trying to do. And we look at what that is here. We're trying to find out what are the elements of the solution. So these elements have to be done over and over again. They can't just be done for the investigations. They can't be done once. You have to bring engineering into your classroom on a regular basis. And that does not mean designing something all the time or designing a solution or identifying a problem. You also want to say, what does it look like on paper? That's what they're going to encounter on a regular basis. And you want to be able to expose students to that. In this one in particular, at the high school level, we have one. I first thought that there was no CCC, but then I went back and I went, oh, here it is. So I'm looking at how new technologies have deep impacts on society and the environment. So this is an environmental problem. I'm looking at it, analyze the costs, benefits, and critical aspects of decisions. All of these are not harming the native populations, so this is how it may go. So I want to talk through this with my partner and unpack those so they become part of what I'm looking at for the work that I'm doing in my classroom.
Step 3, code each item using the performance level description rubric. State Ed suggests that all assessment questions will not be written to the highest or lowest parts of the rubric. Highest numbers are above the standard, but could be done by students in the classroom. The lowest number is below the standard. This level can be used for classroom assessment to show areas of student improvement. Work alone at first, and then for each question, match it to the PLD that best reflects the task, so you decide which performance level the question truly demands. Focus on the cognitive work. One important caution: if you are familiar with Bloom's taxonomy or depth of knowledge, be careful not to code based on verbs alone. PLDs are about cognitive load, what students must actually do, not just the words that are used in the question. Next, work with a thought partner and argue from evidence using the PLD language to justify your thinking, and then come to a consensus on the final level. Pause this video again here so you can pre-read the PLDs for each of the questions in the cluster. I'll do another think aloud so you can hear my thought process again.
So I'm going to go back to LS1-8 for question number 1, and I'm going to look at the PLDs. So if I look at the PLD itself, it says, these are the 5 levels that are that. Remember, this is an NYSED only. So if you're going to do national curriculum, this question or this PE is not in that curriculum that you're there. You're going to have to make those up. I say that in another video as well. So these are the 5 levels. We've gotten indications from the state ed that this is below the standard in level 1. This is above the standard. And that basically questions will be balanced through level 4, level 3, and level 2 questions. So when I go to look at this question and it says, use the information in the model. So I'm going to start looking somewhere around my level 3. Use a model. So it says, use a model. Yeah, use the information from a model. So use a model. Yeah, it could be any one of the 3 of those. To describe or explain, and I'm looking at, does this describe or explain? I'm going, it may not. So I'm looking at it and go, how human production or development maintains the continuity of life. So continuity of life, yes, that's all in here. But I'm looking at involved in human reproduction. Oh, it's definitely not continuity of life. It is more about human reproduction and development. So I'm feeling pretty comfortable about this. Now, this might be where you and your partner might argue, because I'm looking at this and use a model to identify a structure. Identify a structure here. And I'm going, this is a low-level question. But remember what I said back about that DOK or Bloom's. Look at this question. Identifying which model and what are the structures of the model that could support your answer is that although it is the word identify there, I'm not thinking it's there. It's certainly not about continuity of life. So I would go that even though this is a PLD level with the word identify, this is definitely about human reproduction and development. I would argue that this is a PLD level 2. Once again, when you look at the questions holistically in the cluster, you should see a balance of twos, threes, and fours, and you and your partner can take a look at that. When you're designing your own classroom assessments, you should be able to do twos, threes, and fours. Maybe at the beginning you want to start students with some of these level ones and push them at the beginning of the unit, start with level one, and then push them to the level twos, threes, and fours. If you're in honors classes, you should be pushing your kids to level five, or even in a gen ed class, push your kids to the highest level. Have them run 3 miles instead of when they only need to run a mile in a quick amount of time. That's what I did in track. So it may be one of those things that you might want to do with those kids as well.
This process isn't just an exam analysis tool. You can use it to evaluate commercial curriculum. You can adapt it to design classroom assessments with more flexibility. You can use it to analyze your own lessons and units that you've developed for alignment. The work may feel very slow at first, but I promise it gets easier. Over time, you will build an analytical muscle memory, and the process becomes faster and clearer. This isn't just about compliance. This is about strengthening scientific literacy and problem solving for students and for us as educators. Thanks for watching. I'm planning more videos on this channel. Write in the comments what you want to learn about, and I'll try to address your needs. Please comment and click subscribe.